Good day, everyone. Welcome to this session today. We're looking at Unit 3 and we're going to look at cost control, and then we go in Chapter 7 of the study notes. So in the next session or lecture, we're going to look at Chapter 8, looking at cost management. So within this chapter, we're going to look at the cost control aims to ensure that resources are used to their best advantages. So the cost control is to try to maximize the value of money or value for money. Rising prices, restrictions on the use of capital, and high interest levels. Therefore, clients' needs. Client demand that the professional team accept cost as an element of the design. Yeah, if you have to look at prices will continue to change and fluctuate, and thus and it is one of the biggest constraints on any project. So a consultant has to look at the constraints that you have. If that's the budget of the client, that is the budget of the client. So hence one has to look at alternatives, looking at making the project smaller, more efficient, looking at the shape of the project, etc. Past development of the cost control process. So this is just a bit of a history that we're going to look at. It started in the 18th century, where measurers measured and the value of the cost of work after both the design and the execution, basically giving the client an idea of what will this project cost after the design was done. So the main contractor system is fully operational in early 19th century, implies price before construction. So in the early days, most projects didn't have a real good idea of what it will cost, and as it evolved, this information became more clearer, and the science behind estimation beforehand got hold. So thus developing skills to pre-measure, taking quantities from drawings before construction started, and then ultimately producing bills of quantities to provide a rational basis for completion and the cost thereof, basically creating measurement tools that could be used during the control process. So the next development was the introduction of approximate estimate techniques, the forecast of probable tender figures. So what happened was fully measured bills of quantities could be produced, and so historical data could be produced, and that data could actually be used. So I realized that, so the consultants and the whole team realized later on that through cost planning methods, the probable cost could be determined at a reasonable rate and relatively accurately early in the design process by applying the historical cost of previous projects to new projects. So this brings us back to the economics of it. So economics is the study of the forces which determines the present functioning and probable future trends of the whole industry. So looking at what the trends is the transport cost of steel influencing the construction cost on site. So the building economist will need to know the effect of the private and public investment policies and aesthetics. For instance, the security of property. Will this property be the same value later on as now when it's being built on, or can you create value by building a shopping center that a new development surrounding that can actually develop on? All of this plays a part in the whole system of economic forces behind the building industry. Looking, for instance, at the investment of Sandton as an example, how it developed over 40 years ago and becoming one of the financial hubs of the country. So that is a good example of how the economics plays into certain areas. Then Walsche believes that the emphasis should move towards the cost consultancy, and the QS must be fully cognitive of all the relevant cost factors, in addition to providing any traditional services. So it's basically becoming being a professional is more than just producing bills of quantities and so on. It's also looking at the project life cycle and applying more than just the standard construction cost. Obviously, there's a place and for that, but if you are resourceful enough to look at the bigger picture, you can add a lot of value to your client. So the need of cost control. Cost control procedures during the design of the project is vital to keep the total cost within the client's budget. As mentioned many times, obviously the size of the project will have a big influence on the actual cost, which contributes the biggest contributor to the cost of any building project. And where the lowest tender is substantially above the estimate, one should really have a relook at the sizing and estimation of that project. So this is the area where you don't want to be in, where the tenders comes back and it's higher than the budget of the client. So the design needs to be modified and made in or adjusted in such a way that it does fall within the budget of the client, or the project can be abandoned. So the main thing is there's very important decisions that has to be made when the estimations comes in, and the earlier the client can make the right decision, the better for the client. Okay, so the need for cost control continued is there's 7 sources that emphasizes the importance of cost control. So they are the greater urgency to complete the project. Really, the client has time to redesign when tenders come in. So at that stage, time has progressed so far that the client doesn't really have time to go back to the drawing board to do a redesign. So more complicated clients needs more consultants, more difficult to estimate the probable cost. So the more complex the project is, the more difficult it is to get an accurate cost early on. So the employing organizations or public and private adopting sophisticated techniques to forecast and control the expenditure. Therefore, they expect a high level of efficiency from professionals and team members. The main thing is usually when you get into the design and there's, for instance, a mechanical engineer that has to design a boiler system for a water installation, the QS will need that information from that designer. Other example might be if it's a very intricate structural design, the cost advisor will need that information to actually produce the correct estimation, or so that he has all of the information that he can actually base his estimate on. So again, it comes back to you can only do a estimate on available information, thus the emphasis on getting the information as quickly as possible. So the new construction techniques, materials and components create greater problems with regard to assessing the capital and maintenance of cost of buildings. So the main thing, if for instance if you are changing over to a lightweight steel construction method, for instance, have you worked on it? Do you know what the risks are, etc., etc.? Yes, it might be quicker to construct, but then you have different areas in the country that you have to look at. So the type of steel that is used at the coast might require additional waterproofing to the outside, thus limiting the cost saving that you might have on such a building. So the rising prices and restrictions on capital use and high interest rates also plays a part, and you have to be effective with your cost control with regard to that. So your integrated design needs is usually efficient combination of the building and services and the elements in a complex development in the design stage already. So you try and eliminate all of these additional cost items right from the start to make the project as lean as possible. Okay, then obviously we have rising energy costs, also places some limitations on the project as well. Then the role of the quantity surveyor. So what does the quantity surveyor contribute to this whole process? The QS should be involved from the start of the project, from the early stages of the project. The QS quantities provide a sound basis for the decision making by the client and the architect in regard to balancing alternatives in terms of quality and economics. Thus, if you have the quantities of the project, you can start looking at it. So for instance, if you need to look at the basic building cost of a project, if it's only sketch plans and you have a per square meter estimation, now you can start looking at your historical data, what it usually costs for this type of building, and then looking at, okay, this section can maybe be omitted, this section can be maybe trimmed. Why do you need 2 kitchen areas? For instance, you might only need 1 kitchen area. Do you really need this amount of toilets, for instance, for the or services for this building? Why is there a round shape maybe incorporated in the design, or maybe of intricate installation of glass or so? Can those sections be produced economically for this building? An example of that is we worked on a pressure tower, water tower here in Bloemfontein at one stage, and the architect specified curved glass to be installed on the project, and it added a substantial amount to the project. So the alternative that we could get was normal formed glass with butt joints that could be installed on the project, which lowered the cost considerably on the project, because the curved glass plant in South Africa closed down a couple of years ago. So all of those curved glass installations would have had to be imported. So those are the things that you would look at the early stages. And to do that, you need the quantities of that curved glass to make the calculation. What will be the cost difference if we change this amount of curved glass to straight butt jointed type of glass? Thus the quantities were very important for that. So the QS assists the client to obtain the optimum value for money. And then the QS provides advice on strategic planning of the project, which may affect the following decisions. So should we continue to build or not? Is it viable? Because I've got other projects that I have, what I can continue with. Where to build? Will this project be viable in this area? Thinking again at the ghost scraper that we had a look at the beginning of the year or the semester. How quickly can this be constructed? Can this building be opened before the Christmas shopping season or not? Okay, so this brings us to the effect of time and cost on the profitability. The QS should be able to understand that the longer the project takes to develop, the more cost or the less profit the client might have at the end of the project. So the cost controls also extends to giving advice on taxation matters. Cash flow of clients are becoming more knowledgeable, therefore demanding a wide range of expertise. It's all becoming a QS or becoming a construction manager. You're only learning a trade that you can sell to someone. Thus, if you can be more professional, go the extra mile, and look at additional value that you can add to any client. You are expanding the product that you can actually sell. Many QSs go into risk management. There's other options of going into programming, looking at more efficient measurement of projects, and looking at alternatives to save the client money, for instance taxation matters, etc., etc. So as a construction manager or QS, you can be more resourceful and have more items that you can actually present to your client. So substantiation between the capital and running cost to secure the minimum total cost, or the life cycle costing. So it all boils down to be as efficient as possible with the design and the costs of the project. You have to be investigate different ways to produce the building at a lower cost. For instance, looking at the offset between a porcelain tile and a through color ceramic tile, which one adds more value for money. For instance, porcelain tiles usually has a longer life span, but if you consider it might be a shopping mall that wants to revamp or has to uplift the presentability to the public every 10 years or so, then is it really necessary to install products that have a shelf life or a user life of 50 years, etc. So the main thing is to try and get to that point where you can actually advise the client on this is an alternative that you can use if this is the plan to replace this item after a couple of years. Or then obviously the other side of the coin is it doesn't help that you specify a very low quality product that has to be replaced after 2 years. For instance, if you look at solar installations, looking at the contrast between gel or deep cycle batteries against lithium-ion batteries. Lithium-ion batteries cost a lot more, but their lifespan is much longer. So then you can advise the client on the offset of the two. So finding the ways to alter the building to increase the return on investment. Obviously, the client will have a timeline on when he will want to make a return on his investment. So you have to be able to investigate methods to use the same resources to produce a different building, which gives a greater return to the client. Okay, then as a close, we look at the tender arrangements. So tendering procedures aims to select a suitable contractor and obtaining from him acceptable tender offers upon which the contract can be closed. So this is also a very large function of the QS, is to get the contractual side in place, appointing the correct contractor that can actually do the work, and then still some value engineering can be done together with the contractor if needs be, if the design allows for it. For instance, if you do go into construction, you can still show savings by altering the finishes, for instance, and so on. But altering the shape and for instance, the intricate design of a air conditioning system might be too expensive to alter during the construction stage. But for instance, looking at alternatives between porcelain tiles and ceramic tiles, looking at the different ceilings that you might install early on in the construction might have might be a good contributor to a more effective or lower costing building. Okay, and then the chapter just closes with some terminologies. So you can have a look at your study guide. This starts on page 29, and these terminologies include like your cost plan, or your cost plan, which is a statement of the it's just basically a statement of the proposed expenditure on each section or element of a building related to definite standard of quality. Each item of the cost is generally regarded as the cost target and is usually expressed in terms of the cost per square meter, floor area, building, as well as the total building element. So basically the cost plan is to say, okay, this is the budget that we've got, this is what we're going to implement to achieve this. And then your cost check. This is a process of checking the estimate against the allocated or available funds or the targets. So that's basically what the cost check entails. And then the approximate estimation is basically computing the probable cost of new building works at the same stage before the bills of quantities is produced, and it is essential to and an integral part of the cost planning process. So approximate cost is basically just estimated cost of what the building will cost. Then we look at element. The element is a component or part of the building that fulfills a specific function, irrespective of its design. For instance, the specification of a construction, such as walls, floors, your roofs, and many cost plans and cost analysis are prepared on an elemental basis. Just dividing your project into elements so that you can actually do the cost estimation on that. Then you've got cost research, which is very important for the Kiwis, all methods of investigating what the building cost might be. So for instance, you might have a certain type of toilet, or as we call it, a WC, water closet, that you're going to install. It might not be the same one that you installed in a previous project, so you might have to do some research. What will this new product cost? And then you can have a look at what was the installation cost of this toilet in a previous project, but now with this new material cost, what will it cost? And then you can have a look at the cost study. The cost study is basically breaking it down into, it has the following objectives: reveal the distribution of the cost. It relates the cost of any single part of the element to how important it is, and compare the cost of the same part of element in a different building. It considers whether cost could have been apportioned to secure a better building, so maybe shifting the cost around a little bit, and then obtain and use cost data in planning, and then to ensure proper balance between the quantity and the quality of projects. So this is what I've discussed earlier on. Then we get to cost control, and this was what we had a look at today, is all methods of cost controlling the cost of building projects within the limits of a predetermined sum. So basically you can just have a look in the study notes what's said there. And then cost planning is basically, this is often interpreted as controlling the cost. Okay, so the pardon for that. So the cost planning, this is often interpreted as controlling the cost of a project within a predetermined sum during the design stage, and normally envisages the preparation of cost plan and carrying out the cost of change. So this is basically cost planning is what we've been looking at the whole time, but you can't do any control without proper planning. So the old saying of failing to plan is planning to fail applies to this. Thanks everyone. That is basically chapter 7. Yeah, all of the best to everyone.